Welcome back to week 4 for the Geo-Python course. As we're getting started here, I will just ask, if you haven't done so already, to please go ahead and fill in your responses here to our poll question for this week. And we'll maybe slowly get started while looking these poll responses over. Hopefully everything has been going so far fairly well with the material from week 3. So we talked about for loops, we talked about conditional statements. I think we also had a little bit of information about the PEP8 sort of code formatting recommendations from Python organization. That was in the good coding practice for this week. But yeah, let's see what we have here so far for our responses. So I'll start from the bottom since those were added first. And this is a somewhat common issue that's listed here in the first comment about knowing what you need to do and having an idea of how to do it, but not exactly sure how to implement something in the code. And it is a bit of a matter of practice to learn how to take something that you think you understand a way to solve and actually convert that to Python code that produces the solution you would like. The other thing to consider is that with the coding in Python, there's often more than one way to solve the same problem. So it sometimes can be challenging because you might mix two possible ways that we've introduced to solve something in what you're doing. So next comment here is about the nested loops. So normal loops are fine, nested loops are mind-boggling. Yeah, I think this is not exactly uncommon. It takes a little bit of practice as well, just using the loops, and especially when you start nesting loops or nesting conditions within loops, it can be a bit confusing. Here's some comments about the flag exercise, and I was thinking this is something that we have done in the past, is to go through the flag exercise. And if you all would like that, because it's an optional thing, I figured that we could go through and show how to produce the flag using the recommendations that we have in the course in terms of loops and conditional statements. So again, it's possible to do that multiple ways, but I can show you the way that I would do it. And if Hovard feels up to doing it, maybe he would comment at least on what I've done or say how he might do things differently. But it's a fun one just because it is seemingly right there in front of you, but it is a bit challenging to produce the flag. So exercises were a lot more challenging than what were learned in the lesson. So that is sometimes the case. We're always trying to find a good balance between challenging you in the exercises and having things that are maybe following closely what was introduced in class. So that boundary between what we've introduced and what you are asked to do in the exercises is something we're refining in general. But the point in some sense is for the exercises to be a bit of a challenge. And if you're having some difficulties or getting frustrated, then, of course, you're working with partners, many of you, and you can always talk with your partner, but you can also feel free to come to the exercise sessions, and that's what they're there for, essentially, is to be able to give you some feedback and some guidance on how to approach some of the things that we're dealing with in the exercises. I feel like in general, for most of the exercises, we try to be quite fair in asking you to do things that are more or less in line with what we've introduced in class, although they may come at you in a little bit different way than we saw previously. So there was a question here about the difference between using if, elif, and else. That's a good question, instead of just using if for multiple conditions. So yeah, I can maybe demonstrate that one in just a moment, but that's a good question in general. Often have to rely on Python tutor visualizer, which is really slow and maybe not the best way to learn. I'm not quite sure what this one means. Yeah, sorry, I don't know what to say about that. But if there's some questions about things related to this, of course, you can always ask in Slack as well if we want to clarify this. We might be able to help you a bit. I'm just not sure what you mean here. But multiple ways to write the code, not sure which is the best. Yeah, we've seen that basic issue elsewhere. Try and fail again, try and succeed. Yes, this hopefully will improve over time, that there's more, like fewer of these try and fail iterations before you reach the try and succeed. But this is basically learning programming. I mean, they're going to do things wrong a lot of times before you start doing it right. But the thing is that you'll learn over time to avoid some of the mistakes you make early on. And I think you'll find that gradually you'll get more comfortable. The challenge here is we're going to throw new things at you each week. So, it's probably not going to be the case that by the end of the course, you'll just be sitting down and writing the exercise first try and having no problems with it. That's a bit unrealistic. But when you go back to using things from earlier weeks, very probably you'll have the experience that it's much easier to use things like for loops and conditional statements by week 7 when you're very familiar with them. And someone here thankful for the lab partner. I'm very pleased to hear that, because essentially what we've tried to do with pairing people up is to get less experienced people to work with someone who is more experienced. And I do realize that for the more experienced people, that means a bit of extra work for you, but it's also a good thing to actually have to teach someone things about how to do something in Python, because it really forces you to understand it on a deeper level. And we hope that there's a benefit to the experienced coders as well. But yeah, this feedback looks more or less in line with what we've seen for the past few years when we get to this stage in the course. So nothing shocking. And if you're having trouble, if you're feeling frustrated with the exercises, again, I would just remind you to try to go to the exercise sessions, either online or in person. So far, the in-person sessions have not filled up, as far as I know, with people registering on the spreadsheet that's available in the general channel on Slack. So if you are going to come in person, please sign up there. But so far, from what I've seen, we've only gotten to about 50% of the capacity we have. And so there is space to go and join the exercise sessions if you would like. Okay, so let's go here for a second. I'm going to... So partner is so much better than I don't learn as much as I would if I did the exercises by myself. Yeah, well, this is maybe something about, trying to find a way. Well, okay, two things. One is, for the more experienced partners, it's beneficial if you can explain a bit of what you're doing when working through the exercise with your partner. If you're the driver that week, then, it's helpful for your partner to have you kind of walk them through step by step what you're working on. But secondly, for those who are the navigators, or for those who are feeling like they would like the experience, you can absolutely do your own copy of the exercise. We just won't grade it. So if you feel like you want to work through the exercise by yourself after you've worked through it with your partner, just to kind of get the practice, please do. It won't negatively affect your grade in any way. Like, if we see that you created the exercise, we're not going to suddenly go and grade that. We only grade the one for the driver. And if you think it would be beneficial, then there's no reason you can't go through and do your own copy of the exercise. So please take advantage of that. But yeah, I think in the interest of time, I'm going to go here and find my Jupyter notebook from the CSC notebook. So maybe you could open up your CSC notebook session if you haven't already. Again, using the Geo-Python 2021 instance. I've got mine already open here, and I'm going to start by creating a new notebook today. You don't need to do this, but this is just for the purpose of a couple demonstrations. There were some questions in the feedback, one about the if, elif, else combination versus subsequent if statements, and then about the flag. So we can take a look at those two things quickly, and then we'll get on to our lesson for this week. So first off, the difference between the if, elif, and else statements really comes down to how you want to handle the sort of set of operations in your code. So for instance, with something like we saw in the lesson about classifying temperatures, if a temperature is classified as warm, for instance, it cannot be cold, it cannot be cool, it cannot be any other kind of temperature classification. In that instance, you're going to want to use something like an if, elif, and else condition, because you only want to apply a single, like pass a single condition for a given temperature. So if we said, let's take a temperature like 5 degrees, and we could then have inside here an if statement that says if temperature is greater than 15, then we can say print, and we'll just keep this simple and say it is warm. Not going to print the temperature itself back out right now. If we want to check for other, or let's, yeah, we'll say it is warm. If we want to then check for the next condition to say, okay, if it's not warm and we want it to be some other possibility, that's where we can use this elif statement. So if this condition's not true, we're going to come here to this next one, and that could say that temperature is greater than 0. So we won't use quite the same classifications we did before. And we could say print it is cold or cool. And otherwise, if it's not warm and it's not cool, then we're just going to print it is cold. So the way this works is the first test we'll do is to check and see if the temperature is greater than 15 degrees. If not, we jump to the next test. Is the temperature greater than 0? If that's not true, then it means the temperature is not greater than 15. It's not greater than 0, so it must be below 0, in which case we say it is cold. So when I run this, as you would expect, we get it is cool printed out to the screen, and that's because we failed the first test. This condition is true, and then this is executed, and that's it. So once you've executed any of the conditions inside here, none of the others will be considered. Once you pass a single test in a situation where you have an if, elif, and else, or multiple elifs, once you pass a single test in there, none of the others will be executed after that. Now, if I copy the contents of what I have here and just paste them down below, we could write the same thing with another if statement. And let's just make a, because we can't have an else in this situation. If we say if temperature, okay, if it's got to be greater than 0 here, we can say it could be less than or equal to 0 in this last condition. So again, here, what's going to be the situation is I don't think our output's actually going to be any different, because this will still be false. The temperature won't be greater than 15. It will be greater than 0, but it won't be less than 0. So when I run this, I get the same output that I had before. However, if we introduced an intermediate kind of increment within our temperatures, so let's again copy what we have here down here, and let's say that we now want to say that if the temperature is greater than, let's say, greater than 4, just because I want to make sure I catch the 5 in this case, we could say print it is comfortable. Now when I run this, I will have this condition be true, that the temperature is greater than 4 and the temperature is greater than 0. So I'll get output for both of those print statements when I run this code. That's really the difference here. So it's kind of a question of, are you wanting to check each of these conditions independent of one another, in which case you might want to use multiple if statements? Or do you want to check and say, if any one of these conditions is true, we're done? And if we go back to our example from the beginning here, I'll just copy this again down to the cell below here. If we go back to this situation that we had before and we insert this same elif condition that we have here, that elif temperature is greater than 4, to then print it is comfortable. When I run this, the difference you'll see is that as soon as we pass one of these conditions, none of the other parts of the if tests get executed. So we're going to only see output from one statement in this series because we have if, and if that's not true, then do this, and if that's not true, do that. As soon as a statement is true, nothing else happens. So hopefully that helps kind of demonstrate a little bit the difference between how if, elif, and else compare to just a set of if statements that are listed like that. And yeah, if there's any other kind of questions about that, please feel free to maybe say something in the chat or whatever. So the other thing that I wanted to just briefly touch on is about the exercise for this past week where you had to generate the flag. So this was in problem number 4 from exercise number 3. So I just have that open here. And what you saw was we were supposed to produce a flag that looks like this. And when you look at this, it looks vaguely like an American flag in terms of its styling. But if you look at it like in terms of how you might see it in a program, you see basically 7 stars on the first 3 lines, followed by, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dashes. So that's essentially how we want to look at things here, is to say, okay, if in order to reproduce this, we need to have 7 stars, followed by, in this case, I think it was 12 dashes. And we want to do that for the first 3 lines. And then after that, we want lines that are only dashes. And if each character is taking the same space, then that would mean that there should be 7 dashes plus 12 dashes, or 19 dashes in the lower 2 lines. There's a question here in the chat, so I'll just take a quick look there. If you make conditions unique by using them in smaller and greater than, it'd be the same output-wise. No. Yeah, so I mean, if you're right. If you were to take your if statements and put in conditions that, if the temperature is, for instance here, less than or equal to 15 degrees and greater than 4 degrees, then yes, you will only pass one test in that way, because you're kind of bracketing the top and bottom temperature in such a way that that you would get the same output as having if, elif, etc. The difference here is that if you write your if, elif, and else statements in a sort of in a logical way, essentially what you can avoid is having to have that additional condition. So like here, we don't have to say that if the temperature is great, well, okay, if the temperature is greater than 15, we wouldn't need to do anything anyway. But here I don't have to say, for instance, that if the temperature is less than or equal to 15 degrees and greater than 4 degrees, I only have to say, is the temperature greater than 4 degrees? So it kind of cuts down on the code complexity a bit. Whenever you have multiple conditions, you have 2 possible issues. One is it makes your code harder to read. And 2, there's a possibility that you'll mess up one of the conditions and end up with kind of unexpected behavior in the code. So personally, that's why I prefer to do this kind of if, elif, else approach, where I'm only trying to check a single condition. And I know that if this fails, then it must be less than 15 degrees, for instance. And now I'm going to automatically bracket by this elif condition saying, okay, well, if it's less than 15, is it less than 15 and greater than 4? So it simplifies the code a little bit to do things that way. But okay, yeah. And let's just jump back here for a moment to our flag. So yeah, looking at this essentially as a sort of programming approach, you want to basically look at, in terms of numbers of characters, what do I need to produce? And we know now we need 7 stars, 12 dashes on the first 3 lines. And then after that, we need to have 19 dashes on the lines after that. You were also told in generating this flag that you want to produce this pattern when you run the statement print flag. So that's the other challenge here. So we're going to have to basically make a single string of all of these characters that will produce this flag. So that's the task. And let's take a look. So when looking at this, you can do things several different ways to solve this problem. The aim of the exercise is to basically use nested loops to be able to produce the pattern of characters that we expect to see. So in that situation, what we would want to do is have a couple for loops. And I'm going to do for I in range. In this situation, what I'm going to do is have a loop over each line. So for I in range 5, that will give me 5 lines of kind of processing or creating a line of characters. And then I guess I need to add the colon here so it knows that that's a for loop. And then within that, I'm going to have for j in range. And now I'm going to say 19 because I know that I need 19 characters for each line to produce this flag. It's either 7 stars plus 12 dashes or 19 dashes. Now with those two, essentially all I need to do is check and see, first off, which line am I on and which position am I in on that line. So I know, for instance, that when I start writing this out, the first 3 lines are going to be handled differently than the last 2 lines. In terms of my indices, what I want to say is if I is less than 3, which means it's going to be 0, 1, or 2. So the first 3 lines of our flag pattern. Then what I want to do is now in my J condition say if J is less than, and in this case, I want it to be less than 7. So it could be 0, 1, 2, 3, 4, 5, 6. That will give you that'll give you the first 7 characters of that line. So here, I know that if I'm on the first 3 lines and if I'm in the first 7 places of this flag pattern, that what I want to do is flag equals flag plus a star. So I'm going to just proceed through like going place by place, just adding in things that I need. Now to begin with, up here, I'm going to make my flag just be an empty character string. So flag equals, and we'll just make it empty. So then every time I come through this loop, if my value of I is less than 3 and j is less than 7, I'm going to add a star. Okay, nothing too crazy there. If my value for j is greater than 7, that means I'm somewhere past the first 7 characters in my line that I'm working on. Then I'm going to say that my flag equals flag plus a dash. So that's going to append a dash to my line for that line of the flag. So for the rest of the line, I'm going to fill in dashes. Now, the other condition I will want to handle here is if I am not in the first 3 lines of my flag. And if that's the case, no matter what the value is for j, I'm going to add a dash to my line because I'm just filling in dashes everywhere as I go along the line for the last 2 lines. So this is going to put together our flag pattern with one notable exception, and that is so far, we have not added any new line characters to the ends of the lines. So when you get to the end of one of the lines of the flag, if we go back to the flag here just for a second, when we get, for instance, to here, we need something to indicate that this is the end of one line of the flag and the start of a new line, so that we don't just start adding stars and dashes after this point here. So that's the thing we have to handle at this point. And what we're going to do in that case is essentially every time we go through a line of producing our flag, we're going to do, we're going to do these kind of tests and say like, okay, which line are we on? Which character space am I in? And blah, blah, blah. But when we get to the end of all the things that happen for a single line, we're going to say, all right, let's add a new line character. So flag equals flag plus, and then this is the way to indicate that that's a new line character. So at the end of each line, we're going to add that on there to tell it to break the line, and then we'll continue on adding our characters for the next line after that. Once all this is run, we should be able to print out our flag and get the desired pattern. I haven't done this exercise in a while, so it's entirely possible I've screwed something up, but now it's time to sort of put my reputation on the line and run it and see what happens. And lo and behold, that looks like the flag pattern I think we're trying to produce here. Let's go and just copy the one that's here in exercise 3. We can paste that in down here, and let's just make this a raw cell. But that looks pretty similar to me. And yeah, I think we might have gotten it. The idea here essentially is that this looks pretty messy. If you were to do this exercise, I would expect that you would add in some comments here to explain what's going on. So we could say like loop over each line of the flag. And then here, loop over each character on the line. And then we can add another comment above this statement, because check whether we are in the first 3 lines of the flag. So that's what our if statement is doing here. And then check whether we are in the first 7 characters. And if so, add a star. Boy, I'm really killing it on the typing. So that's all we're doing here, is we're adding a star if we're in the first 7 characters. If not in first 7 characters of first 3 lines, add a dash. That's all this else statement is doing here, is just adding a dash whenever we're over here in this part of the flag on the first 3 lines. For the other condition that we have here at the bottom, all we're doing is we're add a dash for all characters on the last 2 lines. So down here, we know there's nothing happening that we need to know which position we're in. It's just like, okay, we know we're going to go through 19 times, and every single time we're going to add a character that is a dash. Finally, add a new line character at the end of each line. That's basically it. So, if you were to do this exercise, of course, we would like to see that you include comments like this that explain what the code is doing. It's going to be very helpful for for both us and for you when you look back at the code to understand things more clearly. But if there aren't any questions, I always enjoy the kind of opportunity to show off the flag. Hovard, would you have done things any differently?
No, I think I would have done it quite similarly, as we wanted nested loops. This is kind of the way to do it. I think you could. There's always as in Python, there's always many ways to reach the flag, but we asked for nested loops and if and else statements. So this is more or less how I would do it as well, I think. Yeah.
Okay. Yeah, I mean, of course, there are other ways to do this. I mean, quite honestly, if I looked at this problem and was left to do it just on my own, most likely I wouldn't bother with nesting the loops, but I would just say, okay, I got 3 lines that look the same and 2 lines that look different. I'm just going to take this whole string of characters and say, print that 3 times and then print all dashes the second 2 times. You could alternatively avoid some of the this inner loop by saying, if you're in the first 3 lines, I don't know if we've ever shown you the trick. I'll delete the flag that's here. But you can do things like 7 times the star character. So plus 12 times the dash character. And if you run that, you'll get 7 stars plus 12 dashes. So you could also very easily generate lines of your flag pattern like that. I don't actually know. Maybe I did this same way last year, or maybe not. I don't remember. But there's several different ways to solve that problem. Okay, we should move on unless there's anything urgent. And I think, in the interest of moving forward, I'm going to just say a couple things here quickly before we jump to our lesson overview. First off is about the grading for exercise 2. My apologies. We're having some issues with the automated grader that we use for grading the exercises. This is something I've been tasked with solving, but haven't had time in the past week or so to really dive into it, but I should be able to get to that later this week. So hopefully by the end of the week, we should be able to grade, or at least start grading exercise number 2. So you'll see feedback about that exercise in the relatively near future. And it should, if we get things working for exercise 2, mean that we can start integrating exercise 3 right after that. So sorry about the delay, and hopefully we'll have that resolved shortly. Hovard mentioned to me that there's still some issues with people cloning the incorrect exercise repository. So please remember that when you create your copy of the exercise using the GitHub Classroom link, that you need to clone that copy of the exercise when you start working on it in the CSD notebooks or on your own computer. So when in doubt, you can always go back to the course page and click on the link to generate the exercise again. It will just take you to your existing repository so that you end up in the right spot, and you can copy then that location to clone it in the CSD notebooks. And finally, about course registration, I think most of the issues with registration are now resolved in Sisu. If you're still having problems, please just send us a reminder in Slack. I think most everyone has been able to be registered now, but if you say something in Slack, then we can try to direct you for how to get yourself registered in the course. So those are the kind of announcements, and let's move on now to our lesson for today. So this week we're talking about functions and modules as our main topics for the lesson. We'll spend most of our time actually looking at functions, and functions are one of the things that we introduce in the course and that are included in kind of programming as a way to avoid having to kind of repeat parts of your code, copying and pasting it, or things like that. A function is essentially a small piece of a program that allows you to easily reuse a few lines of code or many lines of code in a sort of maybe not necessarily intuitive, but very functional way of doing that. So we'll spend some time being introduced to functions to get a sense of how they work in our exercise and lesson for this week. And then we'll talk a little bit about modules, which are basically just groups of functions, sometimes known as libraries in other programming languages. But it's essentially a common, well, it's a group of functions that have a common theme, for instance. So the math module, for instance, would be all functions related to math. And there are many others that exist in Python. So I'm going to go back here to the CSC notebooks, to notebooks, and then L4, and open up the functions lesson for this week in lesson 4. So there's a little bit of a definition here up at the top just to kind of give you a sense. But a function is just a block of organized or reusable code, organized and reusable code that can make your programs more effective, easier to read, and simple to manage. This is essentially just a description you can read through, but probably what's more useful is to start in with actually creating a function. And we'll do that with going back to a task we faced in the first week, that is converting temperatures from Celsius to Fahrenheit. If you're dealing with temperature data from the US and Europe and you want to combine them, this might be a very common type of operation you would need to do. So we can create a function for doing exactly that. In order to create this function, we'll go here to our top cell in the notebook, and we'll start with a keyword here called def. This indicates that we're defining a function. Then you give the function a name. So in this case, we'll call it Celsius to far, F-A-H-R. We'll avoid having to type out Fahrenheit every time. And we'll give it inside the parentheses, a value that it will take into the function and use. It's called a parameter when we're talking about functions, but we'll give it something called temp. And just like with some of our other statements where you start with a keyword like an if or a conditional statement or a for loop, we'll have to have a colon at the end of the line that indicates that's the end of our definition statement for the function. Then, just like with for loops and just like with conditional statements, when you press enter on this line, you'll see the text under here is indented. Everything that's part of this function definition will now be inside of an indented block of code. And in this case, we're going to start our function with a word return. This is a return statement which says when the function is used, here's the value to give back when using the function. And in this case, we're now going to give our equation for calculating the temperature in Fahrenheit when we have a temperature in Celsius. So this is 9/5 times temp plus 32. So this is our entire function definition. And we start again with the def statement, the name of the function. Then we have some variable inside here. This is not necessarily required. There are some functions where you don't need to pass a variable, but that's kind of uncommon. There's usually at least one, but there can be multiple variables in here. And they will be referred to as parameters when they're used in a function because the values will be passed to the function. Then we do some kind of calculation inside here. And then the return statement says that when you use this function, here's the value that should be given back. If your function has a single line, it's sort of like, yeah, well, this is sort of obvious that we're doing something, and that's, of course, the value we want to give back. But you might have functions with 20 or 30 lines where you do a bunch of calculations, and then you return only one result at the end. So I'm going to just do Shift-Enter to run this cell. You won't see any output. What this does is just define the function and make it available to be used if we want to use it. So now we should have a function called Celsius to far that we can use, but in order to do that, we actually need to use the function. And let's do that now down here. So like we saw before, we might want to start out with testing our function with a sort of known value to see whether it's working properly. And we can start in this case with a variable called freezing point that we'll define. So freezing point will just go with the temperature at which water would freeze. And here, our freezing point is going to be defined as Celsius to far of 0 Celsius. So this should convert 0 Celsius, which is the freezing point that we know and is familiar to us, to a temperature in Fahrenheit. Again, when we run this cell, we're assigning a value, so there's no output. So in order to see what we've got, we then need to use a print statement. And let's go ahead and make this an F string. So we can say print the freezing point of water in Fahrenheit is, and then we're going to put a variable value in here. So we'll put the curly braces and we'll put in our variable we just defined, freezing underscore point. So this should print something out. And since it's an F string, we can stick a variable in here and we should get the output of that variable value filled into our string here. We will run this, we get the freezing point of water in Fahrenheit is 32. That is the expected value in this case. 32 degrees is the temperature in Fahrenheit at which water freezes. And everything looks good so far with our function. What happened? Well, we gave a value of 0 here as temperature. And when we called the functions, what we did is we passed in a value of 0 in place of temp. Inside the function, we then took 9/5 times 0, that's going to be 0, plus 32, and we returned that value. So in this case, the function gives back a value of 32 when you use it. We could also check another case if we wanted to. This is just to demonstrate that you can do this in several different ways. You can include the function inside a print statement, for example. So we could have another print here. Let's make it another F string. And we could say the boiling point of water in Fahrenheit. And you can just write F if you want to save some characters. Is, and then again, curly braces here. We could define a variable, or we could just simply say Celsius to far, and then parentheses, because we're using the function, and put in a temperature of 100 degrees Celsius, which we know to be the boiling point of water. So this looks very similar to what we did before, except for now, instead of assigning it to a variable first, we're just putting the function call itself into the place where the variable value could have gone. And when you run this, we now get boiling point of water in Fahrenheit is 212 degrees, which again is the expected value. So it looks like our function is working properly in doing our temperature conversions. Okay. Let's go on to another example here. And that is to make a conversion of our temperature from kelvins to Celsius. So again, occasionally you may need to convert temperatures between different units, and one of them would be temperature measured in kelvins. And let's make a function to be able to do that conversion. Again, we start with a def statement, and then we give the name of some function, so we can call it whatever we want within reason. Okay, we can't call it like true or something as we've seen in the past. We couldn't call it if. That's not a valid function name. But kelvins to Celsius is a perfectly fine function name. Then there's going to be our parentheses, and inside the parentheses would be the parameter we're going to pass, the variable value that comes into the function. And let's call it temp underscore kelvins, just to be clear that the temperature here is given in kelvins. As we saw before, we can then have our return statement, because we don't really need to do much in terms of the calculation here. It's not a heavy thing to do. What we note is that the Celsius temperature is the temperature in kelvins minus 273.15. So if we have our temp kelvins and we subtract 273.15, that will give us a temperature in Celsius. That's our conversion factor in this case. So we could do a shift enter to run that cell. That defines another function. We haven't used it yet. It's just available for use. So we now have our kelvins to Celsius function. And we could do something like calculate what absolute zero is. So 0 kelvins in Celsius. Do that with our kelvins to Celsius function. And in this case, we're going to pass in a value of 0 kelvins. And we could run this just like this. But to note the possibility to you, I want to show you one other thing you can do to be completely clear in how you're using the function, is you can actually give the name of the parameter when calling the function. So you can say temp kelvins equals 0. When you have a single parameter, this doesn't necessarily make sense, but when you have multiple parameters, and sometimes there are parameters that are optional to define, listing their name and then the value that they should be set equal to can be helpful for using the function. So running this line is just going to convert our temperature from 0 kelvins to its equivalent in Celsius. And then if we want to see what we have, again, we have to use a print statement. And we'll make an F string for this one to say absolute 0 in Celsius is, and then we'll do our curly braces and put in absolute underscore 0. And when we run this, we see that the absolute 0 in Celsius is minus 273.15. Again, that is the expected value in this case. We've seen it from how we defined the function, but that's certainly what we would expect. Temp kelvins gets set equal to 0. Let's just take a look at our function. So here we would have a value of 0 coming in. We take 0 minus 273.15 and return that. Sure enough, that's minus 273.15. So we've defined a few functions at this point, and maybe you're starting to have some idea of how the functions are working. And now we'll give you the opportunity to sort of test things. Maybe before we go to this checking your understanding, are there any questions in the chat or anything so far about our definitions of functions and using functions? We still have some more things to cover about functions, so we'll continue with that. But so I don't see anything immediately popping up on chat. So yeah, let's go here to checking your understanding, and maybe this will bring some questions to mind as you try and do this little exercise here. So your job is to produce a function that will generate some text that looks like what's shown on the screen here. So you should make a function called hello. Your hello function should have two parameters, one of them called name and one of them called age. And when you use the function, it should produce a string or a character string that includes name and age in the form that looks something like this. So hello, my name is whatever your name is. I am blank years old. And your character string should produce or should look like this when you run print output. So that is the task here. So your function should produce a string so that when you assign the value from using the function to a variable called output and print that you see output that looks like the text below. So we'll let you get started on that. And when you have finished, please go and put a green check mark in the Zoom so that we can see people are done, and then we can go and have a look at how to do this. Okay, so let's take a couple minutes, try to create a function, and when you're finished, please put a green check mark. Okay, so unfortunately, in the interest of time, we should continue here. And what I can do is start by showing you how to produce the expected output that we have here. So this is actually a little bit more of a challenging exercise than you might think at first, because you have to think of how do I actually generate this string and return that value in a function. But we can start by defining our function. It's supposed to be called hello. So we can do def and then the name of the function we're defining. It's called hello. And there should be two parameters in here. Maybe you were confused also about this in terms of how to list more than one, but you just separate them with commas. So we have one called name, a comma, and then one called age. Those are the two things we'll use in the function, just like that. What we want to return when someone uses our function is a string that contains the text that's shown as an example here. So the return value, we can simply make a string, and we can actually make it an F string. It's perfectly fine to return an F string as a text value here. It should say hello. My name is, and then in this place where it should be the user's name, we can put name. That's the variable or the parameter that's going to be defined when we pass this into the function. Period. I am, and then again here we're going to just put in age. Years old, period. So we've defined our function as hello. That's the name of it. There's two parameters, name and age, that are going to be used in there. And the return value is going to be this string, which we might as well simply make an F string because it's, why not? It's easy to understand this way. And it says, hello, my name is. It'll fill in whatever name is given to it. I am age, years old. And then if we want to be able to do what was said here, that when we run print output, we get the expected output here, we would want to define a variable called output that is equal to hello. And in this case, we would pass in a name. I'll put in my own. An age. I'll put in my own. And we will then create this string by calling the function, and that string that gets returned will be assigned to a variable called output. So we're going to fill in these things inside our function, and that's going to get stored as output. And then to see what our output looks like, we'll then run print output. Let's see if it works. Hello, my name is Dave. I'm 41 years old. That is the expected output in this case. You'll note that you can put in, whatever you want here. You could put in some ridiculous number and run this thing. You could put in any name you want. And frankly, because we're not really checking to see whether we even gotten numbers, you could put in, something else like 40. 1 in text, and that works as well. So our function can take, it doesn't have to be a number here because we don't actually check to see whether it's a number or not. We could put in even a Boolean value like true, and when we run the function, we get the output that we have provided. So that's basically how to do that exercise. And I do realize that that's something a little bit different than what we've done in the earlier examples. So maybe that was a little challenging. There's one red X here, which I'm hoping is not an overly frustrated person, but yeah, if there's any questions about that, please feel free to say something in the chat and we can walk through this again. But in essence, I do realize that this is a little bit different thing, but we wanted to show you how to use more than one parameter. And so how is it possible for the output to be after the return F? Okay, so this is something maybe that's that's a little bit confusing. So our function definition occurs here. this is essentially like making the recipe for what we're going to cook, for example. So like if this is a recipe for making a cake, we don't actually make the cake at this stage, we just write the recipe down. Then when we use the function, that would be the state or the point at which we're actually following the recipe and making the cake. So in this case, when we call the function hello, we then fill in the value Dave in place of the name in the function, and the age in place of the age in the function. And the return statement then gives us back this F string that contains the values that we've provided as our output. So the return is essentially, when you use the function, if you imagine something like the sine function or the square root function, you would pass in a number for the square root, and it returns back to you the square root of whatever that number was. Here, we define a couple values, and we get back this character string. So when we use the function, it then fills in the values that we have provided and returns them. So again, this is like a recipe or a script that allows us to produce this character string, but it doesn't do anything when we define it by itself. So, if I took this output, I'll just make another cell here and paste that there. I can define the function up here, and there's no output that's given when I define the function. It just basically makes the recipe available to us so that then I can say output equals hello. In fact, if I wanted to, I could kind of shortcut this, because in Jupyter, if it returns a text string, that will just be printed out as the output for the cell. I could just say, call the function hello with these two values in it, and then you'll see that the value that gets returned from using that function is given here. Now, note that we've defined a function here called hello. If I was to call something like, something called hi with those values, then I'm going to get a name error here that says the name hi is not defined, because we haven't created a function called hi. So there's nothing that Python will know to do with something like that. But since we have defined a function called hello, when I run this cell and use it, then what I get back is what's given here is the return statement. I don't know if that clarifies things totally, but that's the basic idea with the functions, is that we're kind of making it possible to use them in the future. And then when you call the function, that's when you're actually using it. But yes, yeah, you're right. This is maybe a little bit surprising, because yes, there are parts of the code where you can essentially define something and even have a return statement. For instance, it doesn't actually do anything when you create the function, except for make it available for future use. Which takes us here to something I added to the lesson last night. After thinking about the past few years, we've had some trouble with some confusion that relates to functions and to variable names that are used in functions, or parameters that are defined in functions, and how they kind of relate to one another. So I don't want to spend a huge amount of time on this, but I think it would be good for us to go through this, and then maybe we can take a little break before we come back for the next part of the lesson. So what happens with a function when you create it is you essentially make your script, you make your recipe, however you want to think about it. When you use the function, you provide, for instance, a value, or you could provide a variable name as a value that gets taken into the function and used. The thing that happens is once you're inside the function, it doesn't know what the variable name was outside of the function when it was called. So for instance, here with our example, once I'm inside this function, it knows that there's something that was called name. Here it was given as just a character string, but it could have been a variable value. And inside the function, we wouldn't know anything about what that variable value is on the outside. So I'll show maybe an example here to kind of explain this. And hopefully this will help with your understanding of functions going forward from here. So we're going to start by making a function with a def statement, and we'll call it times2. Times2 is a very simple function. It takes a value in what we can just call number, and it multiplies that number by 2 and returns that value to the user. So we can say that, let's say something like new number equals number times 2. Obviously, this function is not necessary to do what we're doing here, but this is just to demonstrate that, that this is how things are working. What we're going to return then is new number. Again, we don't necessarily need to do this calculation on a separate line, but I'm doing this deliberately in this case. So we have new number equals number times 2, and then we return new number. So whatever number is passed in here should get multiplied by 2. That value gets assigned as number, or new number, sorry. And then that's going to be what gets returned when we use the function. Now note that when I create this, just like before, when I make the recipe, I don't actually create any variable values in memory. So if I print out number, we have not defined a value called number elsewhere in the script and elsewhere in the notebook. When I do print number, I get a name error saying number's not defined. That might be somewhat surprising because we're dealing with number inside this function. How is this not raising an error? Again, if we do the same thing with print new number, we get the same output. We get a name error. New number is not defined. And again, you might be going, how does that work? Because right here, we're defining a value, new number equals this stuff. That's because this is defined inside the function so that when the function is used, a value would be passed in, that value will be multiplied by 2 and assigned to a variable, and that variable value will be returned back to the user. We haven't actually defined any values in creating our function. I hope this doesn't create more confusion than before, but you might also be thinking, well, okay, all we did was define the function. We haven't actually used it yet, so of course we haven't defined any of these values. So let's use our function and see how things look. So we can now say times 2, put in a value of 5, for instance, and let's just do it like this, since we can define we can give the name of the parameter, number equals 5. We run this cell like that. We see 10 comes back. Hey, looks like our times 2 function works. So that's good news. But again, if you still go here and you say, all right, print number, you're going to get a name error. Even though you've said in this function, we're going to take this parameter value number and set it equal to 5. When you print out number, there is no variable name number that has been defined. Perhaps this seems somewhat mysterious at this stage, but this is actually a very important and useful way in which Python is operating. Let's take a look at that in a little bit more detail. So what we have in this case is when we're trying to print out number, we're looking for a variable called number in what's called the global namespace. You don't necessarily need to remember the term here, but the idea is that when you define a variable in a notebook like this, in kind of on a regular line of the notebook, it defines it globally so that it's in memory and we can check its value and things like that. Inside of a function, you're dealing with a different namespace that is only locally within the function. So anything that happens inside the function only knows about the definitions inside the function, so that when you come back to the outside world where we are now, when we try to print number, we simply don't have a variable value that has been defined. So if we take our function that we had before, we can make a version 2 of our function. And we'll call it times 2 v2, so version 2 of our function. Again, it takes a single value called number. Does the same thing we did before, but let's just make this a little bit different. So we'll just say number equals number times 2. We don't need to define new number. We'll just take what we have, number equals number times 2, and return number. So before, our function did exactly the same thing. It just defined a variable called new number and then returned that value. Now we're going to take our same function basically, but just instead of defining new number, we just say whatever you came in with, number equals number times 2, and return that value. So we've created the function, run that. It's made the recipe available to us. And let's now do an interesting test. Let's, in the global namespace, define a variable called number equals 15. Now, if we were to go back up here, for instance, and run print number, now we have a variable value that has been defined that's visible in the global space called number. Let's use our function times 2 v2 number equals number. Again, maybe this is a little bit confusing, but this is the name of our parameter in the function. It's called number. And we have a variable that we're going to pass in also of the same name. We're going to run the function. Times 2 should multiply that number by 2. So we expect to see 30. And sure enough, we see 30. And if we go back and look at our value here for number, you see it is still 15. So even though inside this function we said number equals number times 2, it has not changed the value of number in the global namespace. Inside the function, it has taken some value that has come in. It doesn't matter whether that's called, number on the outside world. Inside the function, it says whatever's passed in as my parameter, I'm going to call number. So it's like, I don't know. I thought about this one for a while yesterday, trying to come up with a useful analogy, and I'm not really sure that I have one, but it's almost as if you were to walk through the door at some place where, like, on the outside world, maybe you're known to your friends by some name. You might be going by your middle name at work and your, initials with your friends. So you could be like DJ or something on the outside world. You come in the door to your office to work and everybody calls you Dan. And you're known as Dan inside the office. As soon as you leave the office, you're known as something else. It's a bit like that, but the analogy doesn't perfectly work for how functions are operating. But essentially, whatever is passed to this function, the function just says, okay, I'm calling you number from here out. I don't care what you were called before, you're number to me. And that's how things are going to work. And so when this value is passed in, I'm going to take that value and multiply it by 2 and assign it to the same value. And that's what I'm going to give back, is something called number. The return value itself, the name of this, doesn't matter, again, to the outside world. It matters only inside the function. And so you can think, number itself is just a value, and this is the name we're using to refer to it inside the function. What we give back is its value, not its name. So this is often a place where people get confused, because you might have variable names that you've defined in your notebook, and then you're using them inside of a function, and you're going like, hey, what's going on here? This seems weird. Why is it not behaving the way that I'm expecting? And that's because it doesn't actually know the name of the variable that you pass in. It doesn't know, like when we say number equals number here, it doesn't know what the name is. It knows what the value is of that number. So it says number equals 15. And so when the function itself gets in here, it's basically saying, okay, this thing I'm going to call number is equal to 15. And I'm going to then do some calculations based on that. So I don't know. I might have to ask you all whether that is in some way clear, but this is sort of nipping a problem in the bud before this becomes a bigger issue and a bigger point of confusion later on when you're working on the exercises. I wanted to kind of preemptively introduce this idea, but it is a little bit more of an advanced thing. But it will help you, I think, in understanding how the functions are working, that they're taking the values of something and they don't care what it was called when the function was called. It only cares about what the function refers to it within the function. And this is a really important thing, because otherwise you would have to be careful. For instance, if you said, let's say you had wanted to use the math sign function, and inside the sign function, it used x as the value that was passed in, you would have to be careful that if you had defined a variable called x in the other parts of your notebook, that it could actually be modified by using the sign function. That's obviously not a desirable behavior. So that is the reason why Python is working this way, that it separates the namespace so that it doesn't sort of like step on existing variable values or existing variable names when you use things like functions. So our last example here is to just show you another thing to be careful for, and that's why they've got this nice big orange caution box. And that is that inside functions, it is still possible to access values from the global namespace when using your function. And I'll let you maybe, that one might take a little time to sink in, but let's show an example here where we create a function called myFunction. I was running out of creativity at this point. And it takes in something called value. That's the parameter name. When we use myFunction, we say value, which is what was passed in, equals number plus 20. You'll note we did not pass in number. We passed in value. And we're going to return value. So when I print my function with, let's say, 11, you might expect to see 11 plus 20 is 31 that comes back, and you run this. Okay, right, I've got to define the function first. You run this, and you get back 35. And again, possibly you're going 35. How does that work? Well, the reason it does this is because number is defined in the global namespace. Number is equal to 15. When we call the function, we don't pass it in, but it's still available for the function to find it. It looks first within the function definition itself and say, hey, is there anything called number here? No. Then I'm going to look to a bigger scope and bigger scope and bigger scope, eventually checking the global namespace where there is a value called number defined. It's equal to 15. You get 15 plus 20. That gets set equal to value and a return value. And sure enough, you get 35 that comes back. If you're interested in more about this, I would encourage you, there's a nice summary about this on the Real Python website, where you can see, for instance, this little diagram. I'll scroll down just a little bit here. Talks about these topics in more detail than I've been able to talk about them in the time that we have here. But it shows you this kind of idea of when you're inside a function, how it looks first to see if there's a value available in the local namespace that's been defined. Is there a number here? Then it looks bigger and bigger. Here's the G for the global namespace. And then finally, it will look for built-in things like values that may be defined by default in Python. So yeah, at the risk of confusing you too much, I'm not going to say more about that, but just refer you to that article if you want to have a look, if you're curious. And yeah, maybe we'll do these last two things about, I just demonstrate that you can use functions inside of a function, and then we'll take a break. And if you have any questions at that point, maybe you can put some questions in the chat. But yeah, let's jump back here to our cases of converting temperatures that we had before. So far, we've converted temperature from Celsius to Fahrenheit, and we've converted from kelvins to Celsius. Now, you could imagine it might be handy to go from kelvins directly to Fahrenheit, and we can do that. And we can do that in a rather clever way in this case. So if we have kelvins to far, we'll create a new function here, def kelvins to far. It's going to take in a value called temp kelvins. And just show you one more possibility here. And that is that we could have a default value for our function that if nothing is provided to the function, if you don't specify a value when you call it, it will default to saying temp kelvins equals 0. All right. That's maybe, yeah, something we can see in just a moment. So we don't actually have to define something when we call the function in this case, because there is a default value that's set. Inside the function, we're going to first convert from kelvins to Celsius. So we can say in here that we'd have a variable called temp, or yeah, a variable called temp Celsius equals kelvins to Celsius. We did this function just earlier. And we're going to take whatever our temp kelvins is. So we created this function earlier called temp, or called kelvins to Celsius. And so that will convert kelvins to a Celsius temperature. We can store that as temp Celsius inside here. So we can use these functions that we've already created inside of another function. That's pretty handy. We could then also make a temp underscore, far for Fahrenheit. And in this case, we'll do Celsius to far, which we created first. And in this case, we'll pass in temp Celsius. So that's what we just stored when we did this conversion first from kelvins to Celsius. Then we'll convert from Celsius to Fahrenheit. And finally, we'll then return our temp underscore Fahrenheit, or far. So that's our new function. In the new function, we use two functions we've already created previously. We first convert from kelvins to Celsius, then from Celsius to Fahrenheit, and finally then return the Fahrenheit value there. Let's use it. So we can say absolute 0 Fahrenheit, F-A-H-R, equals kelvins to Celsius. And because we have a default value here, we don't actually need to define something to use the function as it is shown here. We can just say kelvins to Celsius, and the default value will put in temp kelvins as 0. I maybe am expecting one positional argument. Maybe we do need to give something there. Okay, maybe I misspoke earlier. Maybe with a single value, we just still need to give it. So temp kelvins equals 0. So let's just do it like we have done before. So kelvins to Celsius, temp kelvins equals 0, and then we'll have our print statement, which, as we have done previously.
Are you giving it to the wrong function? You should use kelvins to far, not kelvins to Celsius.
There you go. Yes, thank you. So yes, indeed, we should be able to call this without a parameter there. I'm sort of at the point where I also need the break in the lesson and had typed in the wrong function name. So kelvins to Fahrenheit, yes, we don't need to provide a value here because we have the default value, so that will automatically get filled in. We could put a 0 here. We could also say temp kelvins equals 0. That would also work. There's several different ways to do it. This is a little bit unclear, so I wouldn't necessarily recommend doing that. And maybe it's more useful to actually put a number in there just for the sake of clarity, because otherwise, if someone is unfamiliar with the code, they may not know what the default value is. So yeah, that's something to watch out for. But finally, then we can print out that absolute 0 in Fahrenheit is, and let's put in absolute 0 far. And when we run this, we see absolute 0 in Fahrenheit is minus 459.669999. That is, I believe, the expected value we should have for Fahrenheit. I'm unfortunately not familiar with that. That's not a common reference point for me with Fahrenheit temperatures, absolute 0. But yeah, that's essentially it for the introduction to functions. Are there any questions at this point? I know that we went a little long in the first part here, and everybody needs a break at this stage. But yeah, any questions? I hope the new material didn't totally confuse you, but I expect it will be useful when you get to working on the exercise. So if you have any questions in the meantime, please feel free to put them into the chat. And why don't we take 10 minutes and then we can continue. I'll call it at 10:52. So yeah, let's take a break and we'll continue in 10 minutes.